Hey guys, welcome back. This is Ed Puzzle 5.8. Today we're going to be talking about taking everything that we've been using in the past and putting it all together to solve some problems in context. So it's everything we already know how to do, just in a new context. So let's start with a little bit of review. If we look at our equation, it's in standard form. To solve, we're going to use the quadratic formula. I know it's been a minute since we've seen the quadratic formula, so if we don't remember what it is, we have x equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's our quadratic formula. If it's in vertex form, we're going to solve by square roots. So we're solving by square roots here. If it's in factored form, we are going to factor. So we're just going to use factoring. So standard form, quadratic formula, vertex form, solve by square roots, factored form, we're going to factor. Pretty easy review. Now we're going to move on to our new stuff. I say new, but it's pretty much everything we've already been working with in a different context. So we're going to go through our steps real quick. So step 1, when we see a word problem or contextual problem, is we're going to draw and label a picture. This is going to help us make sense of what's happening and help us figure out what we need to find. So let's look over here. Step 1, let's look at our picture. We have a diver. They're up on a platform 24 feet above the pool. So the diver is going to jump from the platform, and we want to know his height is modeled by this equation. So h of t is the diver's height, and t is the time in seconds. So this is the height, and this is my time right here. We want to know how long will it take for the diver to hit the water. So let's draw our picture. We have a diver. It told us he was 24 feet off the ground. So we have 24 feet here. And our diver is going to jump off the platform and hit the water. So when a diver jumps, they're going to jump up a little bit and down until they hit the water. So this is what my picture is going to look like. So I drew my picture. Now I need to label it. So if this right here, he's 24 feet above the ground, we can say that this is going to be our height. We also want to put our units, so we can say it's our height in feet. So my y-axis is my height. My x-axis right here, the thing that's left, is my time. So we're going to say time, and my time is going to be measured in seconds. So we're going to label time, seconds. If it helps us to see, we can put a t here on this axis to let us know that's where my t value is. This is my h of t, my height. So I have my picture, it's all labeled. So now we can move on to step 2. Step 2, we're going to look and see what is known and what is unknown. So what does the problem tell me, and what am I looking for still? So known and unknown. Let's look at our problem and see. My known, he's going to jump from a platform. His height is modeled. We have an equation here, and it says h of t, the diver's height, t is time in seconds. This is the key right here. How long will it take for the diver to hit the water? When I'm going to be hitting the water, right here, my height is going to be 0. My final height when I hit the water, I'm not above the water anymore. I'm at the ground or at the water, so my known is my final height. So I can say my h of t equals 0. My final height, my h of t equals 0. What's unknown, it asks me, how long will it take for the diver to hit the water? So my unknown is my time, my t value. We don't know what t is. We want to know the time that it hits the water right here. All right, we know what we're looking for. We know what we have. So we're going to go over here to step 3. We're going to determine the form of the equation. So I'm going to look at my equation. Looks like something times t squared plus something times t plus a number. That looks like our standard form. So my equation is in standard form. So step 4 is I'm going to identify the best solution method. Step 3 and 4 kind of go together. The faster we get, we can start doing these two in our head. All right, so standard form, to solve from standard form, I'm going to use the quadratic formula. So I'm going to use a quadratic formula, so I'm going to write quadratic formula. All right, my 5th step, when we're solving, we always want our equation to be equal to 0. It's no different when we're doing contextual problems. We still want it set equal to 0. So let's look and see. I have my equation, my negative 16t squared plus 8t plus 24. I want it set equal to 0, but I can't just automatically set it equal to 0. What I have up here is my h of t, my final height. So in this case, my final height is 0. If my final height was 15, I would set this equal to 15. And then I would have to move it over to get to 0. So this is not always going to automatically be 0, but we have to get it set equal to 0. So this is equal to my final height. In this case, it is already 0 for us. All right, step 6. Now we're just going to solve. We've done this before. We're going to plug it into our quadratic formula. So in this case, the biggest thing is up here in our quadratic formula, we have the variable x. Here we're solving for t. So I want to make sure that we're saying t is equal to my negative b value, so negative 8, plus or minus the square root of 8 squared, my b squared, minus 4 times my a value, times my c value. We want to make sure this is all over the value of 2 times a, which is negative 16. So we have my quadratic formula. From here, we can simplify. So I'm going to get, this is also set equal to negative 8 plus or minus, under my square root, I'm going to do 8 squared, which is 64. And if we type into our calculator this part right here, remember we have a negative 4 times a negative 16 times positive 24. It's going to give me a positive, because I have a negative times a negative, 1,536 over negative 32. I just did 2 times negative 16. Now don't let this number scare you, because it'll end up being nice. I made it nice for us. So let's come down here and continue simplifying. Negative 8 plus or minus the square root. When I add these up, it gives me 1,600 over negative 32. If I just keep typing this into my calculator and simplifying, negative 8 plus or minus, this is going to give me 40. When I take the square root of 1,600, it gives me 40 over negative 32. Now with this plus minus, we can't type this into the calculator. So we have to break this up. We can say t is equal to negative 8 plus 40 over negative 32 and negative 8 minus 40 over negative 32. So I have my two answers. So I can go ahead and simplify them out a little bit more. I'm going to get t is equal to 1.5 and t is also equal to negative 1. So I found my values of t, 1.5 and negative 1. We're going to come over here. We just finished step 6. We're going to do step 7. We're going to put our answers back into the context of the problem. Ask ourselves the question, do they make sense? Are they reasonable? So if I look at this, let's look at the context of my problem. It's asking me how long will it take for the diver to hit the water. So if I come down, all right, it'll take the diver 1.5 seconds to hit the water. That sounds pretty reasonable. It will take the diver negative 1 seconds to hit the water. Now let's think about that. We have time here. We can't have time be negative, right? Something's happening. We can't have time be negative. It can't take the diver negative 1 second. So we want to make a note. I'm going to say negative 1 does not make sense. And then because time cannot be negative. This is really important. I gave us a little sentence stem over here. blank does or does not make sense in the context of the problem because blank. On your test, hint, hint, wink, wink, when we take our test over this, we might be asked to explain why it does make sense or why it does not make sense. So this is helpful for us. So -1, time cannot be negative. So my final answer, it will take the diver 1.5 seconds to hit the water. Notice I write my final answer as a sentence. My final answer always has to be a sentence. So make sure that we write it as a sentence. If you just tell me 1.5, I don't know what 1.5 means, and we will not get full points for the problem. So make sure we have our units and our answer put into the context of the problem. I should be able to basically write the problem based off of your answer. So I should know, okay, the problem asked how long it's going to take the diver to hit the water in seconds. All right, we just have 2 more quick things to go over and then we will be done. Our key words, if we're looking at a problem and it's asking us for the maximum or the minimum of something, so the maximum height, the minimum cost, it's looking for our vertex. So maximum, minimum, vertex. Remember our vertex form highlights this. If it's going to hit the ground, it's looking for our x-intercept. So it's looking for our x-intercepts. It's looking for just up here, what we did up here, our solutions. We're solving when we're finding x-intercepts. We have to convert to vertex form if it's looking for the vertex. So let's flip over our paper. We're just going to focus on these top 2 boxes real quick. So like we said, if it's our maximum or minimum, we have to put it into vertex form. So to do that, to move from standard to vertex form, we're going to complete the square. If we don't remember how to do that, that's in our 5.7 video, we went over it. So we're going to complete the square. To move from standard to factored form, we're going to factor. We're going to factor our equation. All right, the last thing before we're done is I want to make a note up here. When we're completing the square, the value of a must always be 1. This is going to be really important. The value of a must always be 1. So we're going to make sure that if it's not 1, we have to divide everything by the value of a. All right, there should be, make sure you answer all your questions in the Ed puzzle, and have a great rest of your day.